Rolex sells millions of watches, yet most people have no idea what they're
Here is your
actually
receipt,
paying
sir.
for.
Thank you.
Is it just branding, or is there real engineering inside? Today, we're taking a Rolex apart at the manufacturing level. Proprietary technology and obsessive quality control that most people never see. By the end of this video, you'll understand exactly what you're paying for. I'm Thomas, and welcome to Made in World, where we break down the engineering and manufacturing secrets of the world's most iconic watches. We're not here for lifestyle content or wrist shots. This is technical deep dive territory. We'll be exploring the manufacturing processes behind luxury watches, material science and precision engineering, proprietary technologies that brands develop, and the actual measurable differences between watch movements. If that sounds like your kind of content, subscribe now because we're just getting started. Section 2. Vertical integration. Here's something most people don't know. Rolex manufactures almost everything in-house, and I mean everything. While many watch brands buy movements from suppliers like ETA or Sellita, Rolex controls their entire production chain. They cast their own gold alloys in their own foundry. They machine their own cases from raw metal blocks. They manufacture every single component of their movements. They even make their own lubricants. This is called vertical integration, and it's extremely rare in the watch industry. Why does this matter? Because it gives them complete control over quality, tolerances, and innovation. When you design and make everything yourself, you can optimize each component to work perfectly with all the others. You're not constrained by what suppliers offer. Let's start with the foundation of every Rolex, the case and bracelet. Section 3. 904L Oystersteel. Most luxury watches use 316L stainless steel. It's good steel, corrosion-resistant, widely used in watches and medical instruments. But Rolex uses 904L steel, which they brand as Oystersteel. Here's the technical difference. 316L steel contains 16 to 18% chromium, 10 to 14% nickel, and 2 to 3% molybdenum. 904L steel contains 19 to 23% chromium, 23 to 28% nickel, 4 to 5% molybdenum plus copper. That extra chromium, nickel, and molybdenum makes 904L significantly more corrosion resistant. It's actually a superalloy originally developed for chemical processing and aerospace applications. But here's the catch. 904L is harder to machine. It's tougher on tools, requires slower cutting speeds, and generates more heat during machining. Most manufacturers avoid it because of the added cost and complexity. Rolex committed to 904L across their entire steel production. That means they had to invest in specialized tooling and accept higher manufacturing costs. Is the difference visible to your eye? No. Does it matter for long-term durability, especially in harsh environments like saltwater? Absolutely. The cases start as solid blocks of steel that are machined using CNC mills. The Oyster case, Rolex's signature waterproof case design, features a screw-down caseback, a screw-down crown with the twin-lock or tri-lock system, and a crystal secured in a pressure-fit bezel. This creates a hermetically sealed chamber for the movement. Section 4. The movement and proprietary technologies. Now let's talk about what's inside, the movement or caliber. A Rolex movement contains approximately 200 to 300 individual components, depending on the model. Every single one is manufactured in-house. Let's focus on 3 proprietary technologies that set Rolex apart. First, the Parachrom hairspring. The hairspring is the heart of mechanical timekeeping. It oscillates back and forth at a precise frequency, typically 28,800 beats per hour in modern Rolex movements. Traditional hairsprings are made from steel alloys, which have a problem. They're magnetic. Expose your watch to a magnetic field from speakers, phones, or magnetic clasps, and your hairspring can magnetize, causing timing errors. Rolex developed Parachrom, a paramagnetic niobium and zirconium alloy that's completely immune to magnetic fields. You can literally put a strong magnet next to it, nothing happens. But it gets better. Parachrom is also more resistant to temperature variations and shocks. That distinctive blue color, that's from the oxidation process during manufacturing. It's not a coating, it's part of the material structure. Second, the Chronergy escapement, introduced in 2015. The escapement is the mechanism that transfers energy from the mainspring to the regulating organ. It's constantly starting and stopping thousands of times per hour, which creates friction and energy loss. Rolex redesigned the escapement geometry to optimize energy efficiency. The specific improvements include a skeletonized escape wheel that reduces mass and inertia, optimized tooth geometry that reduces sliding friction, and improved pallet jewel contact angles. The result? A 15% increase in power reserve. They went from 48 hours to approximately 70 hours in newer movements without increasing mainspring size or barrel diameter. That's pure efficiency gain through engineering. Third, Paraflex shock absorbers. The balance staff, the thin axle the balance wheel pivots on, is incredibly delicate. Drop your watch, and shock forces can damage it. Rolex developed the Paraflex system, which absorbs shocks up to 50% more effectively than traditional systems like KIF or Incablock. It uses a different spring geometry and mounting system that allows more vertical and lateral movement when impact occurs. Now let's address finishing. Rolex movements aren't decorated with Geneva stripes or extensive hand engraving like some haute horlogerie brands. Why? Because Rolex prioritizes functional finishing over decorative finishing. Gear teeth are polished to reduce friction. Pivot points are precision machined to tight tolerances. Components are deburred and chamfered for reliability, but you won't see artistic anglage or perlage. This is a tool watch philosophy, beauty through precision engineering, not ornamental artistry. Section 5, Testing and Certification. So you've got precision manufacturing and proprietary technology. How does Rolex ensure every watch meets their standards? Through 2 levels of certification. First, COSC certification. COSC, which stands for Contrôle officiel suisse des chronomètres, is an independent Swiss organization that tests movement accuracy. The test protocol involves 15 days of testing in 5 different positions at 3 different temperatures, 8 degrees Celsius, 23 degrees Celsius, and 38 degrees Celsius. The average daily rate must be between -4 and +6 seconds per day. Only movements that pass receive Chronometer certification. Rolex submits 100% of their movements to COSC. Most pass rates industry-wide are 85 to 95%. Rolex's pass rate? Essentially 100% because they pre-screen so aggressively. But Rolex doesn't stop there. After COSC certification, they perform their own Superlative chronometer test on the fully cased watch. This test is conducted on the wrist in real-world wearing positions with a tighter tolerance of -2 to +2 seconds per day versus COSC's -4 to +6. Waterproofing is tested to 10% beyond rated depth. Power reserve is verified. Magnetic resistance is tested. Only after passing both COSC and Superlative chronometer standards does the watch leave the factory. This is why Rolex offers a 5-year warranty. They're confident in their testing protocols.
Section 6, the assembly process. Let's talk about human involvement. Despite all the CNC machining and automation, Rolex movements are assembled by hand. Why? Because human watchmakers can feel tension and resistance during assembly, identify micro variations in component fit, make real-time adjustments that robots can't, ensure each pivot jewel is properly seated, and verify that the movement runs smoothly before casing. The process begins with base movement assembly, dial side first. Then they install the automatic winding mechanism, install hands and dial, case the movement, install the bracelet, and perform final testing and regulation. Each watchmaker is responsible for the watches they assemble. If issues arise later, they can trace it back to the specific person who built it. That's accountability. Section 7. The value proposition. So, is a Rolex worth the money? Here's what you're actually paying for. Engineering and materials, 904L steel that costs 2 to 3 times more to machine than standard steel, proprietary alloys like Parachrom developed in-house, and movements with efficiency optimizations found nowhere else. Manufacturing, complete vertical integration with no outsourced components, Swiss manufacturing labor costs, and investment in specialized tooling and equipment. Quality control, dual certification from COSC and Superlative Chronometer, 100% testing of every single watch, and a 5-year warranty backing it up. Longevity, watches designed to run for decades, a comprehensive service network worldwide, and parts availability guaranteed. Are there cheaper watches that keep time just as well? Absolutely. A $50 quartz watch will be more accurate. But Rolex isn't selling a time-telling device. They're selling precision mechanical engineering, material science, and manufacturing excellence with the brand heritage as a bonus. Whether that's worth $8,000, $15,000, or $40,000 to you, that's a personal value judgment. That's your introduction to how Rolex manufactures their watches. We covered materials like 904L Oystersteel, proprietary technologies including Parachrom, Chronergy, and Paraflex, dual certification standards, and the hand assembly process. But this is just scratching the surface. In upcoming videos, we'll deep dive into specific movement calibers like the 3235, the ceramic bezel manufacturing process, how Rolex's gold foundry works, and comparisons with other manufacturer movements. If you want more technical breakdowns like this, subscribe and hit the notification bell. Drop a comment below and let me know what watch or technology should I cover next. Thanks for watching, and I'll see you in the next one.